Okay, hello everybody, and welcome to Åbo Academy and Academy and Experience Lab. A whole bunch of words there together. So yeah, my name is DIGI-MODE. I work here at Experience Lab Åbo Academy as a project manager and a project researcher. It turned off. Now it's on. Now you can hear me. Good. So yes, my name is DIGI-MODE. I work here at Experience Lab Åbo Academy as a project manager and project researcher. So I do a lot of usability and user experience testing and research on different devices. And today, DIGI-MODE, that's why you are here, a webinar and a workshop. So first things first, let's get these things working. No. So the program or the plan for today. So I'll give you a short introduction of this project, of DIGI-MODE project. And then the project leader, Raiko Toshev, will give a talk about the possibilities of digital twins, how they are used now, what are the possibilities, and how can you benefit from them. And then we'll just present our cases that we've been working on with this project. And after that, we'll go downstairs back to the lab where you had coffee, and there you can test our digital twins cases demonstrations. And hopefully, I hope you will give some good feedback so we can continue develop them to make them perfect. One thing that I want to mention before we start is, well, this project is funded by EU, and we need to have like a participation form. So I will pass this around for you. So please write your name and your company or your affiliation, like school or university. So that would be great. Starting with you here. So yes, to start off, DIGI-MODE. Okay, what is it? First off, it's a collaboration between the labs here in Vasa or here in Österbotten and with companies. And with labs, I mean, we have Novia, they do development, Vasa yliopisto and Technobotnia, they do development, have VR-Tech. We have VAMK and Muova, and of course, Åbo Academy and Experience Lab, and also Co-Proto Lab in Muova. So it's a collaboration between the universities and our different labs. So that's what it is. And as I said, it's financed by European Union and Regional Council of Österbotten. That's where we got the money for doing these things. But why? Well, the basic goal for this project, the DIGI-MODE, has been to promote the usage of digital tools within companies. And with digital tools, I mean, how virtual reality, augmented reality, and digital twins, and how you can use them in your business and in companies, and how these tools can add value. So basically what we did, we have different cases, which will be presented soon. But I think Raiko Toshev, project leader, will talk more about the actual digital twins and what they are. So,
thank you, Joachim. So, hello, everybody. My name is Raiko Toshev. I am a project manager and lecturer in University of Vasa. And I am the head of 3D printing and scanning lab and also virtual and augmented reality lab. So before we dig into the digital twins, let's get the concepts right. So you can see on this horizon line on the left side is the real environment. So this is the world we are in. And on the right side, this is the virtual environment. So totally immersive, disconnected from reality digital model. If we start augmenting 3D models, it can be text data on top of the real environment here, then we are talking about augmented reality. And if we start adding something like a camera feed from the room into the virtual world, then we talk about augmented virtuality. Everything in between, it's called now extended reality, ER, XR. These are the concepts that we deal with. So what is a digital twin? It's quite popular nowadays, but it's an old concept. It started with early designs for aerospace, for NASA, etc. So highly technological models that needed a representation of the physical devices or process. So it's started as a digital replica. Also, it's stated it's a collection of visualization of real-world sensor data in virtual places. So it can be not only the 3D models, it can be data, text, as I said. It generates new insights using simulation or real data feed in the feedback loop. And the application, it's giving you insight of how the process can work back to the original objects. Here is another representation of this, something that we have done in Technobotnia. You can see with our full-size 3D printed humanoid robot. We have the digital model in Unreal game engine with object-oriented programming script controlling the Arduino PCB, the electronics, and then controlling the physical robot and vice versa. So the physical robot controlling the digital model in a real-time two-way directional feedback. What you need as a hardware, these are the glasses. The hype around the technology started with something called Google Glass project. Nowadays, the state of the art for the augmented reality see-through binoculars are the HoloLens 2 devices. The popular virtual reality glasses that you don't see through, you are immersively into the digital world. These are the Oculus or Meta now, Meta 2 Quest and HTC Vive, but also Microsoft have a range of VR glasses. But also to consume content, you can do it on your mobile phone or on your tablet, so you don't need a dedicated hardware. Though the price tag of this hardware have dropped significantly, so it's now accessible to many small companies, startups, etc. On the software side, to develop content, or when you are talking about industry application, the gamification of industry, the two more popular game engines, Unity and Unreal, but also there is a open source framework like the WebGR or WebXR, softwares like Blender XR, etc. The commercial VR platforms, Steam, mostly you have been using probably, also Oculus Store, the PlayStation Network, and Microsoft Store. So these are providing VR, AR content, and then the XR framework to develop SDKs. So again, these are, some of them are quite inexpensive, so it's easy to dive into the technology and create something compared to what was years ago. And into the development of immersive environment for state-of-the-art virtual training and simulation, you can see some of the examples. Companies have experimented a lot for different ways to train the workforce. Obvious advantages are you are doing it whenever you want, whatever time. You are not tied to a physical location. And good cases are applied in machine operation, in maintenance training, factory layouts, but also medical practice, etc. Augmented reality applications have been demonstrated with Airbus for the maintenance, remote support and training, and also ABB Robot Studio for offline programming have a direct plugin that you can preview what you're doing with the robots. The future of collaborative design, when we are talking about something like additive manufacturing or BIM models in construction, so you would like to have a meeting room where you can get team members from all over the world coming online and discussing and visualizing, exploding the bill of material for components. So obviously, virtual reality platforms offer a lot of possibility here. NVIDIA, Holodeck have invested a lot in providing such tools. Improve also is a VR teleconferencing software for CAD teams. And Outspace have been recently bought by Microsoft to provide virtual meeting rooms for multiple users and avatars. What we do in University of Vasa a lot is manufacturing simulation and providing digital twins and virtual reality technologies for factory layouts, which allows not only to visualize it, but optimize the layouts, to calculate some key performance indicators about production and compare automated lines versus manual lines, etc., to make a business case where it really makes sense to automate processes. You can do it quite realistic. You will see downstairs, we have been doing 3D scanning to create custom avatars, and the way you can make the avatars move with full body tracking is something that we have been testing in this project. So you can make job training, industrial tasks, tutorials, visual aids, also ergonomic planning, and practice many different tasks inside the environment. But also IKEA and even like Alibaba, big companies have been looking at other possibilities for virtual shopping, virtual stores, virtual fitting rooms. You know, now comes the holiday season. If you are ordering clothes online, that's something that can help you get the right sizes on the first go. So there are the applications also for education, museums. There is like a Google exhibitions, Google excursions from the Steam store that you can straight away download and preview in the VR goggles. So to recap, digital twins provide value across the whole enterprise. Never mind if you are a big multinational corporation or a small startup, just starting with the design, with manufacturing sector, with sales and marketing, with services, training, and operation and logistics. You can see application of the VR in all these sectors, and what you will test later on downstairs. It's some of these examples that we have been developed in-house. Okay, so back to Joachim.
Yes, thank you. Do we have any questions? We will have a test afterwards to see if you know what digital twins are. Are you feeling comfortable? Yes, good. Yes, use cases. We'll go through, or we'll just a short explanation of what we've done. First off, I want to talk to you about a little bit about our architectural architectural twin, digital twin. So first off, Experience Lab and Novia has created this application. So we have Dennis, please stand up so we know. The best programmer in Vasa, almost. And then we have Søren Andersson at the back as well, have been working with me and Dennis in this project, or in this case. I'd like to show you a video that will be hopefully self-explanatory, so you see it with a video, and then we'll talk a little bit later on.
In architecture, visualization is crucial. And in this case, a digital twin proved to be a powerful tool for planning buildings for physical spaces. This application is called Master.
The idea of this tool was like to take like a first step using like the abstract concept of a digital twin that is basically a replica of an existing built environment, and see how it can be developed.
In architecture, the design process begins by studying massing. This is a process where the physical limits of buildings are tried out in an environment. It is one of the most important architectural design considerations. In this project, we have worked with an architect company in Finland and developed a proof of concept for a digital twin solution to simplify the process.
The idea of having this tool is to have like a quick method at early planning stage, so that helps making like quick decisions at the beginning of the planning. We can basically quickly scan an existing built environment, and then we get like a base with high integrity in terms of scale and colors and all like the important environmental aspects, and then put that into the planning process or the developing process.
During the initial phase of the project, Experience Lab and Novia worked together with the architect company to define the needs and goals of the application.
We came up with 4 main goals. The first one, that it should be a really fast way to do massing. It shouldn't be too complicated. It should also be easy to use the software, so you don't need a lot of support. It should be a very simplified user interface. The third thing was that it should be affordable. We could use like consumer hardware, no expensive equipment. The fourth and last goal, the architects wanted a presentation and collaboration tool.
To meet these goals, our team of experts combined our skills from architecture, technology, and user experience in a co-design process. We needed a way of creating a digital representation of the environment, a digital twin. To meet the goal for the massing process to be easy and affordable, we use photogrammetry and a standard consumer drone. The drone is programmed to take several pictures while flying in a grid pattern over an area. The images are then processed to create the 3D model. The model is then imported into the master application. We wanted the application to be platform independent, and therefore, we decided to develop Master as a web application.
For developing the Master app, we chose the WebXR technology, which is an open framework for developing VR-enabled web applications, which run inside of a web browser. With WebXR, you can run virtual reality applications directly on a VR headset without installing any application. You can run it as if it was a regular website.
Multiple users can experience and collaborate on a design at the same time. Master supports multiple devices, such as VR and AR headsets, mobile phones, and tablets.
During the development of the Master app, we did several usability tests at the Experience Lab. We invited the architects to the lab, and they performed several tasks. We mean that they used the application and tried out all the features. And that way we got feedback from the architects, and that was very valuable for developers. Then they could do some changes to the application, and we stayed on the right track.
After a few rounds of the developing, the tool became as expected. It had all the commands that we wanted to have, and then the end result, it met our expectation, and we think it's a good tool to be used in the future.
Masser supports several different simple massing elements like cubes, boxes, and cylinders. The structures can have different kinds of roofs. The structures can be positioned in the landscape and the volumes can be modified. If you want more information on the Masser app, visit digimode.eu.
Yes, so that's what we have been doing in this project, creating this application for architects. Do we have any architects in the audience? Software architects, close enough. Yeah, but basically we identified a problem and then we had tried to actually solve that problem through this application. And when we talked with the architects, so they had a big problem, or they had not a big problem, but they had an issue when doing concept designs. So there's a lot of emailing back and forth from city planning for the buyer and so forth to make small changes. With this application, as Dennis talked about in the video, so it's multi-platform, so you can do it simultaneously on a web browser or in a VR headset. So basically, in a sitting meeting, you can make all these small concept changes directly, which saves time and energy. So the solution was the Masser application. And in the video as well, you saw that we tested this application in our lab. You saw a video where we used eye tracking and so forth. So today, afterwards, when you get to try all these digital twins, so we have my colleague Matthias there. If you can please stand up, so they know you. If you want to test, we have our eye tracking up and running, so you can see how we do usability test.
I have a question. Do you use some data from that simulation? I mean, if you place the building, do you have sizes of that building, or you make some changes to landscape? Do you monitor it somehow, or it's only like the visual?
No, it's not only the visual. I mean, the massing, you'll get like square meters, basically, an approximation of how large that and the volume. That's what you get. But that's what the architect needed in this early stage when they do like a concept design. Any more questions? I'll give over to Dennis.
Yeah, so I have been developing a kind of extension project to this Masser, which is a photovoltaic panel planning module for the same framework. And I will show you a short video here which will show it in action. I call it the PV Planner software. So let's see here. No? Yes. Yeah, so here's the old barracks in Vasa, which were scanned by NACARC using drone photogrammetry. This is the same framework now as the Masser app, except it's in PV mode. You can rapidly put out an array of PV panels. You can see here the energy calculations done by a tool called PVGIS. You can adjust the panels and try to see how many panels you can fit into a single roof. This model now should supposedly be in real units, like in real meters. You can change the incline of the panels to see how that affects the energy production. You can change the panel size between a few standard dimensions. You can also add multiple panels, the panel arrays, and the calculations will be done individually for each one. You can see here the months, January to December. You can really see in winter how little energy you really get from a panel in the middle of winter. Here's the first person mode where you can observe the panels from like a real perspective. And just like the master app, this module also works entirely in virtual reality. It can actually be used and edited entirely from it in VR. You can see it's first person here from VR perspective. Is actually really quite interesting to see how it will look. Okay, so yeah, so as I mentioned, the primary purpose of this tool is to be able to plan and visualize panels on top of a real environment, just like the master, except this time it's like PV panels. And you can estimate the energy production based upon the real life location of the building in question and the orientation, of course. And yeah, the PV plan is based upon the foundation of the master. It's basically just a small add-on. And just like with the master, you can work cooperatively with multiple people, like customers. And the energy calculations done by the tool are from the DIGI-MODE online tool, which is a application which can be used to estimate energy production for for PV panels. And this tool uses the solar radiation databases from several sources to estimate, get you a rough estimate of the energy production based upon the incline of the panel and the azimuth and the location on the planet. So it should be fairly accurate. And yeah, this PVGIS tool was created by the Joint Research Center from the European Commission in-house science services. Okay, so that's all I have to say about this tool. So I give the word over to Jari. Yes.
Is there a button you can press to optimize energy?
You can do that in PVGIS, the online tool. There is an option that if you don't specify the azimuth or the slope, it will optimize it. Of course, it's a bit difficult to. Now it could easily be added to this tool as well. Yes.
Okay, thank you. So our case was around creating an industrial service digital twin. My name is Jari Ratilainen. I am here supported by João Pereira and then Kimi Wenström, who is not here. We come from WAMX Design Center Muova, and we in this case, what we did was build a digital twin for service. And usually these digital twins have been built around like tangible things like physical assets, engines, or something else. And here we try to kind of show the power of visualization when building a case around something that is by definition, an intangible thing, a service. So the demo was built in GoProtoLab, a collaborative prototyping platform. You are free to come and see that at the demo. So I wonder if this just runs, or do I have to press? Okay, hopefully something happens. So our case company was a bulk logistics company called RL Trans, and what we did, we started to have some development sessions with them to kind of understand what is their process, how do they manage, and the aim goal was to simulate these specific service moments. So kind of identify the key events that happen inside the whole service journey. So there you saw the packing and the warehouse. Here is the delivery or order. So a customer kind of orders material as they see that their containers are running low. They are setting up an order for the delivery. Then it will come to some type of data center or order management center. And then the process kind of starts with the actual cars being cleaned and getting a certificate, then loading the actual material inside the warehouse. And quite many different data points can also be introduced into this visualization. And then the truck arrives to the customer location for delivery, and usually there is also some type of qualifications or training or something like that that is related to the delivery process in the customer's locations as well. So I just want to briefly show you that we started with standard like service development toolkit to map out the process and do this early stage quick prototype. So this was basically the first digital version of it, and then we progressed into something that you see now in the demo with more like visual elements and more realistic assets as well. So the end result was basically to first build this like service journey that is easily understandable and can be communicated to the end customer in a visually appealing way. And what was also discussed was these different types of metrics that can be integrated into the digital twin. So it's not just a visual presentation of the service, but what type of key metrics could it include? In the left-hand side, these are quite standard ways of measuring performance, but especially the service development indicators that you have on the right-hand side are something that we kind of found out during the process that when bringing something intangible into the digital realm, it's more easy to visualize and understand, for example, these service development related things like how many number of service moments do you have in the whole process, how many tasks does the driver have to go through when he goes through one single delivery loop, or how many interactions with the client, or how many potential choke points there are, and kind of utilize this framework to also streamline the actual process and not just visualize. So how to use that in a meaningful way to develop the processes as well. So I want to just show this as the last thing, that usually like data science is described or they are described in 4 different stages, starting from a descriptive thing of or descriptive phase as to how things are now, to visualizing the current status. And this is kind of what is the level of our demo at the moment. But if we were to have more access to real-time data or company like business intelligence databases or stuff like this, we could progress into the more value generating things, to do diagnostic things, so understand the current system better, or do predictive things, create future scenarios, or even do this prescriptive activities to kind of solve issues inherent in the system as they are now. And of course, with that, you could also prototype new ways of running the service in a digital environment without actually committing to starting buy new fleet or building new warehouses. Okay, thank you.
Thank you. So the last demo model of the digital twin that we developed during this project together with a company, Cubitor here, was training for painting measuring in construction companies. So the VR technology have been used for many years, as I said earlier, with different scenarios in firefighting, aviation, police, military, oil and natural gas, chemical, travel, tourism, different sectors. So the benefits that you can train wherever you want, whenever you want, safely, and calculate and measure the thing like in a real world are the triggers that we had, and then we had a feedback loops. So this project actually was running more than a year now, and we'll be finishing on February, but we are applying continuation. So if you have some ideas, let's discuss later on. So the video for the construction painting, if I can ask you, Kim, to start it. The magic finger. Okay, so we try to make it as realistic, immersive as possible, because from the previous projects we had the feedback that the user experience greatly depends on the photorealistic models. And we try to incorporate the functions that are meaningful when you are creating a business offer or when you are actually training a person to join the team and to operate a scissor lifter. So first of all, personal protective equipment, and then calculating the statistics like the speed, the use of the paint and the square meters painted, again to make probably an offer or to count like key performance indicator. Something for visualization, how a complete paint work will look like, and visualization also free form bird eye view for the construction site. That's what was required, and that's what was implemented. So we have been using this gamification on several levels. I will talk after the video, but you will try it firsthand. So this is like a spoiler review of the demo. Okay. Navigation. Using the controllers, getting to the actual goal. Real-time speed. Yeah. Okay. You can go deeper and deeper into the details depending on the actual user case. If you are really want to calculate how much force you have on the wrist or etc. So it can be used, as I mentioned earlier, for ergonomics, etc. Okay, the business indicators that we calculate for cost estimation, dimensions and service calculation, timing and painting usage. And because of the gamification concept, we made it in 3 different levels, on 4 different levels. Level 1, instructions, how to use it. For beginners, sometimes it can be quite overwhelming, the whole experience, so you have to have clear instructions, controller function, directions explained, and then how the personal protective equipment, what kind of it should be used, like a checklist for the safety of the site. The level 2 is the actual painting statistics, speed, average estimation time, area covered, and color schemes. We used some of the standard construction companies' book to code the formulas for this prediction, and for the preview of the color scheme, like a customizer for the client. Level 3 is actually the scissor lifter for the high demo painting. You need to go through training, so we will have some of the actual people that are doing this giving us some nice feedback how realistic this feels. But okay, to learn the controls about driving, lifting up and down, following direction, turning and parking, or planning for the best optimal way to place the scissor lifter, it can be beneficial to train before you go to the actual site. And level 4, the full go through in the construction site, implementing all this function into one with a gaming score and fulfilling the tasks. Okay, that's it. So if you have some questions regarding the demos now, or we can discuss now or later downstairs in the room. So
Yes, do we have any questions?
The consumption of the paint is calculated depending on your spraying time at the spot, or
yeah, on the time and how many layers of paint you do. So usually it's 2 layers, and we have built in also the time that you have to wait for the paint to dry. So overspray also, if you go many times on one and the same side, it's still calculating that you are underperforming compared to the optimal. Yeah, do we have another side? No. Any other questions? Do we have the list of participants somewhere? Did everybody manage to sign up? Yeah. Okay. So maybe last words from me. I told you that this project is finishing February next year. You still have some time to give us some feedback. We can still develop another photovoltaics installation demo in Unity. That's our plan. And then we are planning to make a EV charging station for households. So to see where is the optimal position, either inside of a garage, depending on your vehicle charging point, inside, outside, calculating the distance between the cables, meters needed, etc. So, and then we plan to make a follow-up of this project. So again, public-private partnership, we can work with companies, not directly for the companies, but given a generic scenario, it would be a pleasure to make it more realistic. Yes, please.
photovoltaic shade, shadow on the environment, things like
Something we have been discussing. Yeah, we could add occlusion into the PV planner. That we have been discussing that, but in the way that you can actually see whether something is obscured by the sun and take that into account. We haven't done it yet, but exactly. So we assume it's directly face the panel surface must always be directly facing the sun, so the roof cannot be over the panel blocking it.
So because of that, my question, if there is no obstruction of sunlight, it's always available. Illumination will face south, and you make the angle of the panel at the left. That's it. So what difference from a technician perspective to have?
Well, yeah, I guess it would depend upon what way the roof is facing. So if it's even viable to make it face that exact direction, if you have a pre-built house. Yes.
Then you compensate plus 50 degrees or minus 50 degrees, depending on where you are.
Yes.
For example, maybe, but so my question is understanding the
Will we do that?
When you compare to
I can speak about that directly because we didn't manually do the optimization. We have the possibility of doing optimization through the PVGIS tool, since they allow you to optimize both the incline and the azimuth of the panel. And in that way, optimizing the incline at least could be beneficial, even if you know for sure what direction it should be facing.
And the more immersive experience. So, for example, when you do the installation, they will require some of these models, how they will look like. You have to agree also with your neighbors that they will not be visually obstructive, etc. For the simulation, you can also understand this monthly much faster and easier. So that's probably also for the end client more beneficial. So for the technician, okay, can be more or less the same, but for the end client or for the general manager, if you have to install 1 million panels, then you have to, if you have to scale it up, then it's getting more like a visual experience, how much square meters they are into it, and we can add the different functionalities.
Okay, thank you so much for the questions, and let's continue with the discussions downstairs. So let's head downstairs so you can try out our digital twins, and hopefully we get more questions. Thank you so much.
thank you.
Sorry. My bad. I should have.